Have a look at this image. In 2006, an innovative magnetically levitating train crashed during a test trial in Germany. With a speed of over 200 km per hour, the vehicle collided with a maintenance vehicle. The result? 23 casualties. Ever since, a maglev train has not been realized in Europe. A catastrophe like this must be avoided at all times. Therefore, safety is the most important topic for Hyperloop design. Safety. That is what I'm going to talk about in this video. First, we will have a look at the current modes of transportation and what we can learn in terms of safety. Afterwards, I will tell you about some large risks for the Hyperloop. Furthermore, the importance of testing will be described, and finally, I will explain how it can be determined if the Hyperloop has a sufficient safety level before it can be used. When we look at other modes of transportation, a lot can be learned. In particular, high-speed trains and aircraft are useful to look at. For high-speed trains, the interior design can be useful, for example. Think of the seat pitch, aisle width and door sizes, which are all designed with taking into account efficient and fast passenger flows. In case of emergency situations, passengers have to disembark the train as fast as possible. The similarity of a Hyperloop with an aircraft is that they are both operate in a capsule that is secluded from the environment. If something happens with an aircraft, it is not possible to brake and come to a stop directly. An aircraft has to deviate from its intended route to stop at the closest airport available. However, that will still take quite some time, and thus additional safety measures need to be on board. The same will be the case for a Hyperloop. Only by learning from current modes of transportation is of course not sufficient to make the Hyperloop safe. The potential of Hyperloop lays in the differences with the existing modes, and therefore will be different risks. I will highlight 3 of the largest differences that influence safety. The first difference is the near vacuum environment. A Hyperloop tube will be a larger vacuum chamber than there currently exists. But what will happen if there is a hole in the tube? How dangerous is a dent in the pod? Can the pods and its passengers be transferred safely from the station to the vacuum tube and vice versa? Many risks to think about when designing a Hyperloop. The second difference is the speed of the Hyperloop, which is even higher than airplanes. The top speed of Hyperloop is way higher than current maglev trains have ever reached. Still, it is desired to have a headway as low as possible to increase the capacity. This will bring major challenges for the communication, as this needs to be extremely reliable and trustworthy. And is the magnetic braking system capable of bringing the pod to a safe stop if needed? It might be useful to know exactly what the technology is capable of at high speeds. The third difference is the enclosed environment of the pods in the tubes. It is not possible to just exit the tube whenever one wants. This is particularly dangerous in emergency situations. If something happens within the pod, then it's crucial to evacuate its passengers as soon as possible. Especially these 3 differences with existing transportation show the need for thorough testing of all subsystems of a Hyperloop. This needs to be done on high speeds to show that the Hyperloop would be safe in all possible conditions. However, that is currently not possible yet, as there is nowhere on the planet a Hyperloop tube that is sufficiently large to reach speeds of over 1,000 km an hour. For example, the SpaceX Hyperloop tube is only 1.5 kilometers in length. To assure that the Hyperloop is 100% safe, many tests at high speeds have to be conducted, and the high-speed test facility is thus necessary. Next to the safety tests, certification is needed to determine if a Hyperloop is safe at the end of its development phase. Certification is the process of providing an approval for a new vehicle. And this can be arranged in two ways. The first option is similar to trains, where multiple organizations are allowed to approve vehicles. The second option is comparable to aircraft, where a single organization is responsible for the certification. For the Hyperloop, the second option is preferred because all knowledge will then be present in a single organization. When the Hyperloop certification process is completed and the first link is constructed, it is finally time to board the Hyperloop. Although it will still take a long time, I am really looking forward to that moment, and I hope you are as well. However, always keep in mind that human safety is priority number one when designing a Hyperloop. Thank you for listening today, and I hope you learned a lot about safety.